students. In the last class, we have seen the reciprocity theorem. We have related the areas shape for two infinitely large plates, and we got the various shape factor properties or the characteristics. You cannot write this way. The point is, you cannot divide the emitting body into two uh, portions, and this way you cannot write, but you can divide the receiving body into two portions and you can write it like this. So this is what we have seen regarding those two. Also, we have seen the shape factor for crossed string method. This is a crossed string method. If you have body one and body two of two different lengths of infinitely large plates, so then L1 and L2, if you take, uh, the corresponding F12 will be sigma crossed strings minus sigma uncrossed strings by the corresponding L, that is L1 or L2, you will put for F12 or F21 correspondingly. So if you have theta as an angle between those two plates, then you'll be using 1 minus sine theta by 2, that is equal to F12 or F21. Both will have the same thing. If this L1 is not equal to L2, then you have to make use of the graphs to solve uh, those particular questions. So this is a simple problem. Theta is 90 degrees. We have solved. This is a three-zone enclosure we have taken. And what is the shape factor calculation? We have done here. Shape factor formula we have seen here. And then this simple problem we have solved in the last class, determine the shape factor of the inside surface of a hemispherical body with respect to itself. We have one we have taken. The concept is like, first you will make use of the sum of shape factors is equal to 1, that is on one side. The other thing is you will make use of the reciprocity theorem. First one is shape factor sum, second one is reciprocity theorem. So using these two, you will solve this. You will imagine a flat disk here, that is 2. So for that flat disk, you will have 0, and since this F22 is 0, F21 will be equal to 1, and F12 is equal to this one by your reciprocity theorem. From the areas, you will get that F12 is equal to 1 by 2. So if you take it in the sum of F11 plus F12 is equal to 1, you will get that F11 is equal to 1 by 2. So this is what we have solved in the last class, and I have left this question for you. Determine the shape factor of inside surface of a semicircular duct with respect to itself when the heat transfer from the ends is negligible. So let's solve this now. So here, what you have is, you have a semicircular duct. It is like this. This is a semicircular duct. It's like this. And we call this as body 1. Did anyone solve this? Imagine that there is a surface 2 here. If anyone solved, please let me know the answer. Or you will solve it now. So you have a semicircular duct here. This is a semicircular duct. And what to do now? You need F11. You have to find out this value. So F11 plus F12 is equal to 1. You know this. F22 plus F21 is equal to 1. You also know this. Also, you know the reciprocity theorem, that is A1 F12 is equal to A2 F21. You know this. And now you will understand that F22 is equal to 0. Why F22 is equal to 0? Since this is a flat disk, the F22 will be equal to 0. And that will imply that F21 is equal to 1. If F21 is known, you can make use of the reciprocity theorem. That is F12 you can write is equal to A2 F21 by A1. In this, you have this F21 as 1. So simply put, this F12 is the ratio of A2 by A1. What is A2 here? Area of this flat disk. So if you consider a length L here, this is your length L. A semicircular duct will have length and it will also have a diameter. Okay. If this is the case, what will be the area? It is rectangular area. So what you get is L into D. L into D you will get in the numerator, and in the denominator what you get is A1. So how do you get A1? What is the surface area of a cylinder? It is 2 pi r into L. So that is pi d into L. But you have only semicircle here. So I have to take half of it. So what you will get here is DL and DL will get cancelled. So ultimately you'll get 2 by pi for F12. What you need is actually F11. F11 is equal to 1 minus F12. That will be equal to 1 minus 2 by pi. So it's like 1 minus 2 by 3.14. You can do for yourself, you'll get the value. I hope this is clear to you. Is that clear? Somebody please respond.
Yes, sir.
Yeah. So this kind of simple questions you may get in your 2 mark these things, and even for the competitive exam also this kind of questions are important. So for more questions of this kind, you may refer to the old competitive exams like GATE, IES papers. You will get so many questions of this kind. The concept is again the same. You have to make use of some of the shape factors and the reciprocity theorem. So use the combination of these two to get whatever the shape factor he is asking with respect to the same body he will ask most of the times. So for that, you will uh, be solving all those problems. Right. Let us move to the next topic now. This is an important thing here. Here, what we do is we take the radiation heat exchange between two infinitely parallel gray bodies. Let me write that. Next concept is radiation heat exchange between two infinitely parallel gray bodies. For this, I will be taking two gray bodies here. This is my body 1, and here I'll take a parallel body plate. Essentially, I'm taking a plate here. So this will be body 1 and this will be body 2. And let me say that the temperature of this body is T1, this body to be T2, and the absorptivity of this body is alpha 1, absorptivity of this body is alpha 2. And let me say that there is a radiation emitted by body 1 onto body 2. So let me represent that here with this one here. That is E1 is the energy emitted by body 1 onto the body 2. Okay. So if that is the case, and what will be this one? What will be value of this one? Something will come out of it. If the absorptivity is alpha 2, what will be the value of this one?
E minus R.
E minus. What will be absorbed here? Alpha 2 into E1 will be absorbed. And the remaining thing will come out. What is the remaining thing? 1 minus alpha 2 into E1 will be coming out of it. Okay. So what will be absorbed on this side here? What will come out here? What will be absorbed? This much 1 minus alpha 2 into E1 into alpha 1 will be absorbed onto the 1. So what will be absorbed here is alpha 1 into 1 minus alpha 2 into E1. So that will be absorbed. And what will be the remaining thing? 1 minus alpha 1 into 1 minus alpha 2 into E1. This will be emitted. And what will be absorbed here? It is again alpha 2 into 1 minus alpha 1 into 1 minus alpha 2 into E1. So what will be emitted? This whole story will go on. Okay. So once the electron splits, this whole story will go on. So the same thing we will keep writing. So to get a mathematical form to this one, what I will do is I will write this as Q1 net, meaning it is a net energy change in body 1. There's a net energy change in body 1 that will be equal to E1 minus, what should I write here? See, E1 is what is coming out. Okay, that is the remaining all things are absorbed at various levels. So if I have to write those things, first one, this one. Okay, next one to write will be here. Next one to write will be so. So whatever that is coming out of it is E1. Whatever is coming in is the remaining parts that I'm going to write here. That's what net energy change, the energy conservation meaning. So for that, uh, here, what I'll get, first term is alpha 1 into 1 minus alpha 2 into E1. Alpha 1 into 1 minus alpha 2 into E1. What will be the other term? The other term will be alpha 1 into 1 minus alpha 1 into 1 minus alpha 2 square into E1. Plus so on, we will have the expression. So if I take the E1 on this side, and here I can take E1 common, and alpha 1 into 1 minus alpha 2 also can be taken as common. So what will be the expression here? Alpha 1 into 1 minus alpha 2 into E1 will be 1 plus. Here you have taken alpha 1 and 1 minus alpha 2. So what you get here is 1 minus alpha 1 into 1 minus alpha 2 plus the other term I'm writing here, 1 minus alpha 1 square into 1 minus alpha 2 square plus cube plus power 4, so on, you will get the expression. So to write that expression, okay, what I'll do is I will write this term 1 minus alpha 1 into 1 minus alpha 2 as P. 1 minus alpha 1 into 1 minus alpha 2 is equal to P. Let us say that is equal to P. So then the equation will become Q1 net will become E1 in E1 minus alpha 1 into 1 minus alpha 2 into the E1 into 1 plus P square plus P cube plus so on is the expression. So tell me what will be the term in the brackets here? What is this expansion?
1 minus p whole power minus.
1 minus p all to the power of minus 1. Correct. So that is equal to E1 minus alpha 1 into 1 minus alpha 2 into E1 into 1 by 1 minus p. So that is what is p? It is 1 minus 1 minus alpha 1 into 1 minus alpha 2. So this is your expression. If you simplify this expression, you take this LCM and do all the calculation, what ultimately you'll get is alpha 2 into E1 by alpha 1 plus alpha 2 minus alpha 1 into alpha 2. You will get this is your Q1 net. Okay. So this is your expression here. This is very important expression that you should remember. Q1 net, if you write here, you will get E1. E1 meaning sigma to the T1 to the power 4. So these are the absorptivities of the bodies here. That is body 1 and body 2 absorptivities you will get here. So also, you know what is called as Kirchhoff law of radiation. As per that, alpha is also equal to epsilon. So the same expression you can solve for your emissivity in place of absorptivity. Here you put emissivity and you will get the same expressions kind of. So ultimately at the end, what you get is in place of alpha, you will put epsilon. That's the only change. By this is epsilon 1 plus epsilon 2 minus epsilon 1 into epsilon 2. This is your expression for Q1 net. Okay. In terms of emissivities. This one in terms of absorptivities, this one in terms of emissivities. That is the only change here. Okay. Similarly, you can write for Q2 also. Okay, you will get the same kind of derivation. On the Q2 side, you take the sum of these things, this one and this one and so on. Okay, or you follow a different kind of procedure, whatever may be the case. What you get ultimately is Q2 is equal to similar to your Q1 net. Here alpha 1 you will get and then E2 you will get in the numerator and the denominator remains the same alpha 1 plus alpha 2 minus alpha 1 alpha 2 and then Q2 net we can also write in terms of epsilon 1 into E2 by epsilon 1 plus epsilon 2 minus epsilon 1 into epsilon 2. So this is a simple expression for finding out the uh, you know radiation heat exchange between the two bodies. Okay. So how do you find out the radiation heat exchange? You need Q1. For that, you will take Q1 net minus Q2 net. You will take. So if you take this, the denominator remains the same for both the expressions. I can take it as common. So what I get in the numerator is epsilon 2 into E1 minus epsilon 1 into E2 by epsilon 1 plus epsilon 2 minus epsilon 1 epsilon 2. This will get what is the E1 here? E1 you can express in terms of uh, T to the power of 4, sigma T to the power of 4. It's like a black body radiation. Sigma into T1 to the power of 4 minus epsilon 1 into sigma into T2 to the power 4 by epsilon 1 plus epsilon 2 minus epsilon 1, epsilon 2. You will get this. Okay. So that is the case when you take the black body radiation. If you don't want to take the black body radiation, you will also get the expression. If they are black bodies, what happens? The epsilons will be equal to 1 anyways. That we cannot define. So what you have to write here is epsilon 2 and to epsilon 1 into sigma 1, sigma into T1 to the power 4 minus epsilon 1 into epsilon 2 into sigma to T2 to the power 4 by epsilon 1 plus epsilon 2 minus epsilon 1 epsilon. So this is your expression. You can simplify this expression, that is epsilon 1 into epsilon 2 into sigma is common in both terms. So T1 to the power 4 minus T2 to the power 4 by epsilon 1 plus epsilon 2 minus epsilon 1 epsilon 2. This is what you will get. So if you further simplify it, sigma into T1 to the power 4 minus T2 to the power 4 by the epsilon, if I take it in the denominator, it is 1 by epsilon 1 plus 1 by epsilon 2 minus 1. This will be your expression. Okay. So this can also be written like Q12 is equal to IF. This means IF means the interchange factor or equivalent emissivity, people call it, into sigma into T1 to the power 4, T2 to the power 4. This is this will be the final expression where IF is equal to 1 by epsilon 1 plus 1 by epsilon 2 minus 1. So this is how your expression will be like. Also, this kind of expression you can write using the resistance concept. Okay. So that resistance concept I'll be telling you shortly. But before that, let me solve a simple problem based on this one. Either you can use this formula or this one, anyone you can use.
Sorry, it will be 1 by IF.
What? Yes, it is 1 minus this like this. Yeah, you are right. Let it's not what it is 1 by IF is equal to IF. This is also called as equivalent emissivity. Equivalent emissivity. This is the other term that we must be knowing. Sometimes this will be given in question, or sometimes this can be asked in question. Okay, right. So let me take a simple problem here. Insert. So in this question, we'll not be taking everything that is there in this question. This is actually question based on the radiation shield. We have not seen the radiation shield yet. So we will solve the question that doesn't have the radiation shield here. So we will be solving this part of the question. This part of the question we will solve. Okay. Without radiation shield, also we will see later on. Okay. Here in this question, he has given the T1 value. He has given you the T2 value, epsilon value, epsilon 2 value. So it's a simple thing. So if you want Q12 here, be it will be like sigma into t1 to the power 4 minus t2 to the power 4 by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. So, the T1, T2, epsilon 1, epsilon 2, we will substitute them. How about sigma? Please speak out. What is the sigma value? Sigma. It is a constant value, that is a Stephen Boltzmann constant value, that is 5.67 into 10 to the power of minus 8 watt per meter square Kelvin power 4. Okay. So the T1, T2 values here, they are given in the Kelvin only. So you need not convert the values here. So you can directly substitute them. 800 power 4 minus 600 power 4 by the emissivity is 1 by 0.5 plus 1 by 0.8. 1 by 0.5 plus 1 by 0.8 minus 1. So please quickly calculate and tell me what is this value.
7056.
7056. What is the unit of this one?
Watt.
The unit of this one is watt per meter square. Why watt per meter square?
We have
Tell
not
me.
taken area no sir in sigma
We
area.
have not taken area anywhere. Okay, if you look at this derivation, area concept is not taken. So what is the meaning of it? You have taken per unit area. So that's why the unit of this Q will be watt per meter square. This must be kept in your mind. Okay, fine. Let us go ahead and see what is the concept, the same concept using the radiation shield also. The same concept we will see with the radiation shield also. Before that, I must be telling you what is called as a space resistance. Phase resistance. See, this resistance will be offered by the space in between. Say here, you have this case itself. Okay, if this is the case, here we have not considered what is the resistance offered by the space. Okay, so space will also offer certain resistance, like you do for the conduction case. Here you take conduction heat transfer. Here you take conduction heat transfer. In between, you will take convection heat transfer. That is for space, but that kind of thing is not taken care in this particular case. So, to take care of that space resistance, we will have a formula here. That formula is nothing but RSP, meaning space, is equal to 1 by A1 T of 1, 2. So how do you get this formula? Tell me how to get this formula. Hmm? In Q, you will take sigma into A1 into EF1, 2 into T1 to the power 4 minus T2 to the power 4. Okay, if you take the temperature change by Q, what you get is 1 by IA1 F12, you will get. Okay, so that is the way you get it. Anyways, that's a whole story different, but I don't want to go into detailed story of that. So simply put, this is the space resistance formula, right? Also, you get something called as surface resistance. What is the resistance provided by the surface? RS. RSUR sometimes. I will write it like RS. So what will be formula for this one? Formula for this one is 1 by epsilon into A. Okay, similarly, I told like uh, Q12 you can take, and from that you can take the delta T and this whole thing. Then again you will get this formula. Again, I'm not going to that part. You can look for yourself. So these are the formulas for the space resistance and the surface resistance. So now, if I have to write it for the case that we have just seen, okay, what we have seen here, we have a body one, here we have a body two, and it between there is a space. This is a surface, this is a surface. So, what will the resistance circuit here? This is one resistance. This is another resistance. This is another resistance. Likewise, we will have three resistances here. This being RS1, this being RS2, and this being RS. SP, I have to say. This is R space. Okay. If this is the case, what should be my Q12? So Q12 will be equal to the change I have to write. What change should I write here? Okay. For writing that, what I will have is I will have a concept of EB1 and EB2. That is the black body radiation I will take here. So EB1 minus EB2 you will have in the numerator. And what will be in the denominator? If this is RS1, let me call this, it is having epsilon 1, and this is called an epsilon 2. These are the emissivities of the bodies. So what you will have here, 1 by epsilon 1. This is a formula for the surface resistance, 1 minus epsilon 1 by epsilon 1 into A1 plus 1 by A into F1 to F1 you can take plus 1 minus epsilon 2 by epsilon 2 into A2. I hope this is clear to you. ఇది అర్థమైంది కదా? Simple like your resistance concept. You have resistances in series here. That's why I have added them together in the denominator. Okay. So I'm doing it a bit faster. If you are not catching it anywhere, please let me know. So what is the EB1 formula? It is sigma into T1 to the power 4. EB2 formula is sigma into T2 to the power 4. By this thing, if you do, the A1 will be equal to A2. A1 is equal to A2. Then I can take A1 as common. And how about F12? Here, both are equal, areas are equal. Then obviously F12 will also be equal to 1. Okay. So if that is the case, what happens is I can take the area common. 1 by A1 I will get 1 minus epsilon 1 by epsilon 1 plus 1 plus 1 by 1 minus epsilon 2 by epsilon 2. This is what you get. So I'm taking the area into numerator sigma into A1 into T1 to the power 4 minus T2 to the power 4 by, in the numerator I can write 1 by epsilon 1 minus 1 plus 1 plus 1 by epsilon 2 minus 1. This minus 1, this plus 1 goes. What I get is Q12 is equal to sigma into A into T1 to the power 4 minus T2 to the power 4 by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. So what I got the same expression that I got previously. So the same thing you can do both ways. Either you can do using the derivation or simply using this resistance concept. So mostly we will be using the resistance concept as we go ahead in our calculations. But in the exam, he may ask you the derivation also. That's why I told you the derivation. Okay. So the same formula you will get either using the resistance concept or using the this one, the derivation. Okay. That's the thing. The same problem that I've solved, you can solve either using the resistance concept or using the formula direct, derivation formula direct. Anyways, that is the point here. Then let me quickly go to the resistance, sorry, the radiation shield. Radiation shield. What is this radiation shield? Let us see. So the radiation shield means you want to reduce the radiation heat transfer between the two bodies. Here you have two bodies here. Okay. You don't want the radiation to happen. Okay. Then what you will do? This is the body one. This is the body two. It is having epsilon one. It is having some epsilon two. Okay. So you don't want the radiation heat exchange to happen between these two bodies. So then how will you achieve it? You will achieve it using the radiation shield. You will introduce a material here, and this material will have very less epsilon value, that is very less emissivity. As the emissivity of this body is less, what happens? Whatever that is taken from the other body will not get emitted to the other body. That means it is going to shield whatever the radiation heat exchange that is happening between these two bodies, one and two. So this is the radiation shield. If I have to write the resistance here, this will be for body one. Then I will have space. Then I will have shield. Then I will have space again. Then I will have body two. This is shield. This is space. Is this clear? How did I get this? How did I get this resistance circuit? ఇది అర్థమైంది కదా వాళ్ళకండి. Is this clear? అర్థమవుతుందా లేదా? ఇది అర్థం కాకపోతే ఏం అర్థం కాదు, అందుకే క్లియర్ గా అడుగుతున్నాను, చూసుకోండి. దిస్ ఇస్ you will get RS1 surface resistance you will have here, RS2 surface resistance you will have here. You have R space here, R space 1. This is R space 2 you will have here. And here what will be this for this one? For shield, what you will do?
Surface.
Shield is a figured. Shield is what? It's a
Surface.
surface. So R, yes, you can write. Okay, that is one way of doing it. But in some problems, he might be giving you this epsilon in a different way. That is, you will have so and so epsilon on two side. That is epsilon 2 1. He will write on this side. You will have epsilon 1 2. That is the same radiation shield, the same surface can be having two different emissivities on two different sides. Okay, that can also be given. If that is the case, you will have two resistances coming here. Okay, so that one we will see as we move on. But for now, we will take only single one here. Let me call this as epsilon 1 2. This is epsilon 1 2 simple thing. We will take and solve it. If this is the case, what will be Q12 formula? Tell me. Tell me, what is there in the numerator? Please speak out. మీరు మాట్లాడాలి. I have to take the difference. The difference is EB1 minus EB2. That is sigma into T1 to the power 4 minus sigma into T2 to the power 4. This one. So that's the difference in the numerator. In the denominator, you should take this one plus this one plus this one plus this one. The sum of all these things. So I'm writing that directly in terms of formulas itself. 1 minus epsilon 1 by epsilon 1 plus resistance is 1 by A1 F12 plus 1 minus epsilon 1 2 by A1 or A2. Both will have same area. So you can write both the things into epsilon 1 2 plus 1 by A2 F1 2. You can write here F21 actually. This is plus 1 minus epsilon 2 by A2 epsilon 2. Is this clear? If A1 is equal to A2, that implies F12 is equal to F21 is equal to 1. Then what you get in the numerator is sigma into A1 into T1 to the power 4 minus T2 to the power 4 by 1 minus epsilon 1 and all those stuff you will get. I'll write it here. 1 minus epsilon 1 by epsilon 1 plus this will be 1 by 1 plus 1 minus epsilon 1 2 by A1 have taken down epsilon 1 2 plus 1 by 1 plus 1 minus epsilon 2 by epsilon. So here epsilon 1 by epsilon 1 is 1. This is minus 1 plus 1 gets cancelled. Here you have minus 1 plus 1 getting cancelled. So what you will have ultimately is Q12 equal to sigma into A1 into P1 to the power 4 minus T2 to the power 4 by 1 minus, sorry, 1 by epsilon 1 plus this is 1 by epsilon 2 on from this side I am taking. And what you get here regarding this epsilon 1 2 is minus 1. This is what you will get. So based on the given question, you will write this expression and do it for the values that are given here. Let me take the previous one. Previous one problem. Yeah, here it is. This is the question that we have done. So the same question we will do now. So he has given emissivities on both sides for this question. Emissivities on both sides for this question. This is 3 1, this is 3 2. So if that is the case, what will be the resistance? This is one resistance 1 plus then space you will get, and then resistance due to shield will be 2 times here. Okay, resistance due to shield on one side and resistance due to shield on the other side. So that's the only difference you have to write. This is 1, this is 2. So you can write it like 3 1, 3 2 as per the question given. And then you will have space, resistance, space, and resistance due to the surface again, that is R2. This is surface, this is surface. So if you write here, the Q12 will be equal to sigma into A1. So I will write the difference first, sigma into T1 to the power 4, sigma into T to the power 4. That is the difference in the denominator 1 minus epsilon 1, the epsilon 1 A1 plus this resistance due to space is 1 by A1 F12 plus resistance due to shield is 1 by epsilon 31 by epsilon 31 A3 you can take. 3 he's calling it as essentially as a third body. That's the difference. 1 minus epsilon 32 by epsilon 32 into A3 plus space 1 by A2, F21, F23 is actually, this is 3, 2, 3, because 3 will come in between. Uh, and this one is space cavity 1 by epsilon 2 by epsilon 2, A2. So if, see, these are plates. For plates, A1 is equal to A2 is equal to A3. If you are having something like a cylinder, you are having a sphere, then A1, A2, A3 will not be equal. You have to substitute A1, A2, A3 appropriately and get it. But in this particular question, since these are plates, you can have A1 is equal to A2 is equal to A3. Also, your F12 will be equal to F13 is equal to F23 is equal to 1. All these will be equal to 1. This will be equal to sigma into A. I can take it as common. A1 I will put in the numerator into T1 to the power 4 minus T2 to the power 4 I will get. So if I simplify this expression here, what I get here is 1 minus epsilon 1 by epsilon 1 plus 1 plus 1 minus epsilon 3 1 by epsilon 3 1 plus 1 minus epsilon 3 2 by epsilon 3 2 plus 1 plus 1 minus epsilon 2 by epsilon 2 8. So what I get here is Q12 equal to sigma into A1 into T1 to the power 4 minus T2 to the power 4. Numerator remains the same. And the denominator, you can transform it into like 1 by epsilon 1 plus 1 by epsilon 2 minus 1 plus 1 by epsilon 3 1 plus 1 by epsilon 3 2 minus 1. So this is how you will get it. So in the given question, he has not given the area to you. The area you consider it as 1 and the remaining things you substitute here. The sigma value is 5.67 into 10 to the power of minus 8 and the T1 value is 800 given in question, 800 power 4 and T2 600 power 4 by what is epsilon 1 is given 0.5 and zero point 0.8 1 by 0.5 plus 1 by 0.8 minus 1 plus 1 by 0.31 is 0.1 in the question. This is 0.05 minus 1. Tell me what is the value.
508.03.
508
Point zero three
8.03
two.
watt per meter square. So this is your Q12. What is the Q12 without shield? In the previous problem, we have done that. What is the Q12 without shield? You got
Seven
it
zero
around
five six
7036
five
watt.
56 sir 56.
56, whatever. It is around 7,000. You can see how much it reduced. The 7,000 has become 5,000, 500. So the reduction is really huge. Why is this reduction happen? It's because of the radiation shield. If you have the radiation shield in between, it will reduce the heat exchange between the bodies like anything. That's the point here. I hope that is clear to you.